learned from previous years. So this is what we did on Friday. Okay, so some of you already have the notes filled in. This is just going to be kind of a brief review on factoring. Those of you who weren't here are filling in your notes package, okay, with the examples and such, and okay, and just getting caught up with the rest of the class. Okay, so some of the things, okay, factoring. When we're talking about factoring, factoring just basically means we're taking something that's kind of big and we're breaking it down into smaller parts. So when I use the word factor and I say, for example, like the number 12, and I say, tell me the factors of 12. What I'm looking for are two numbers that you multiply together to get you 12. Those are what factors are. Two things that multiply together to get you the end result. So for example here, okay, if I wanted to know, okay, the factors of 12, I usually write them as pairs because they're two things that multiply together. So 1 and that number are always going to be a factored pair. See, so if I'm here, let me just get my pen all sorted out. Okay, so the factors of 12, I'm going to say 1 and 12. Okay, and then I'm going to say 2 and 6, 3 and 4. Okay, those are all the pairs that multiply together to get me 12. Okay, and if I asked you for what are the factors of 18, you do the same thing. Okay, if you needed to use your calculator, right, you go 18 divided by 2, 18 divided by 3, 8, and every time it comes together, like that there's no decimals, that would be a factor. Okay, hopefully, for most of the numbers, right, there's mental math going on. Okay, so for the factors of 18, you'd know you'd have 1 and 18, 2 and 9, 3 and 6. Okay, 4 is not a factor, 5 is not a factor, and then we hit 6 again, which has already been partnered up. Okay, so you have to be able to figure out the factors of numbers. Okay, so that's a bit of a mental math. And then we have something called the greatest common factor. So the greatest just means what's the biggest number between all of the things that we're looking at. So in this case, if I want the greatest common factor between 12 and 18, I would list out the factors of 12 and out of 18, and I'd look through them and I'd say, which one is the same in both of them and is the biggest number? So for example, both of them have 1, both of them have 2, both of them have 3, okay? But the biggest one that they both have is 6. Okay, so you're always looking for the greatest factor that's common between them. And so we just shorten it. GCF just stands for greatest common factor, and we're going to say that it's 6. Okay, then of course, so like that's, like guys, that's like junior high. Okay, so that should not be at all in any way something that's new for you. Okay, in grade 10, we started doing, okay, greatest common factors and throwing in variables as well. So for example, the thing that you're going to do is you're going to look at the coefficients. Remember, the coefficient just means the number in front of the variable. Okay, so coefficients are the numbers. Okay, then determine the GCF of the variable. So this is where we look at the lowest exponent. Okay, so if they both have an x, okay, maybe one has an x squared and the other has an x. You can only take out one x because we have to look at the lowest exponent. Okay, so for example here, I could say, okay, between the 4 and the 6, okay, my greatest common factor is going to be a 2. So I could divide both sides by a 2. And they both have an x in there, so I can divide both sides by x. But I just have to double check, and I always have to pick the variable that has the lowest exponent. So if you don't see an exponent, right, it's the invisible math. Okay, it's assume that it's a 1. So here I can take an x out of both of them. Okay, some people find it really helpful to show under each term what the greatest common factor is. Now just remember to take that number and put it out in front. Okay, and then you actually can do the division. 4 divided by 2 is 2. X squared divided by x gives you x. 6 divided by 2 is 3. Okay, and x divided by x is, well, just 1. Okay, so the x's cancel out. Okay, now, so some people were taught this way, that you take the GCF out and you like show the division underneath. Okay, other people were taught that your GCF goes out in front and then you just write in the brackets whatever's left over. Okay, I'm good with both forms and I'll try to show both forms. I learned this way, so I typically do this one, but I don't mind if you want to like show the GCF underneath. As long as it comes out in front because this is a factor, and everything in this bracket is also a factor. Okay, so do you see how you have two things that are multiplying together to get you your one expression? Okay, so in between here, in between the 2x and the bracket, whoops, I just made a mark here. That was weird. Let me just undo that. Oh, I can undo my mark too. There we go. Okay, don't forget between the 2x and the bracket, there's a multiplication sign. Okay, it's that invisible math. We don't write it in, but you know that it's there, right? These two are being multiplied together. Okay, so state the answer in factored form. That's what it looks like in factored form. Now, if you're not sure if you got the factors right, what could you do? How could you check? Yeah, you could work your way backwards, absolutely. If you wanted to double check, all you'd have to do is distribute through the brackets. Okay? So you could just remind yourself here to check. You could just go through the brackets and you end up with 4x squared plus 6x, which is your original question. And then that way you know that your factors are correct. Okay? So this is kind of what we talked about. This is what we worked on. So in our course, hey, you guys have to be awesome superstars at greatest common factor. And the second type of factoring that we're going to be doing is difference of squares. Okay? So really just the two types. Okay, we're not going to be doing decomposition and grouping and some of the other ones. Okay, we're going to be doing greatest common factor, GCF, and we're going to be doing difference of squares. So let's just make sure that we can do greatest common factor. Okay, so when you're doing this, right, you're just saying, okay, what's common between these terms? What can I take out? I can take out a 2 from both terms. Okay, and then when I do the division, I end up with 10x minus 3. Okay, so we're just pulling out greatest common factors. Okay, for those of you who just got your notes, if you're like, oh, I remember this, go ahead and work ahead. Okay, and if you're like, it's been a while, okay, just tune in. Okay, here I'm looking at the 16x to the power 4 and the 4x squared. Okay, I can actually take a 4x squared out of both of them. Okay, so just remember to take whatever your GCF is. This is my GCF, okay, and put it in front. And then you write whatever's left over. Okay. Other hints, tips, and tricks. Okay, so when we're looking at 25 and 45, okay, we're looking at greatest common factor. You're like, okay, 5 can go into both of them. Okay, they both have a D, so we can pull out a D. What exponent are we going to take out with the D? Yeah, yeah, the lowest exponent between those two terms. Absolutely. Okay, so we have 5D4. Okay, we have 5D plus 9. Okay, okay, I'm kind of like, I'm assuming that you guys recognize that D to the power 4 divided by D to the power 4, that these like become 1, like when they divide out, that they become 1. If you're nodding with me because you're paying attention and you're in agreement. Okay. All right. Okay, so for these ones, okay, we're just doing GCF for right now. Okay, so go ahead and finish these up. Okay, so you're looking for just greatest common factors. So for example, 3K. I'm going to kind of just go fast because most of the class was here on Friday, and so they've done this. 9, whoops. Okay, GCF first. Okay, some of the things to remember. If your original question has 3 terms, okay, and you pull a GCF out, your answer, like in the brackets, what's left over, better have 3 terms still. Okay, the one I think that sometimes messes people up is when the GCF is exactly the same as one of the terms. So you have to remember that this, when it cancels, like this cancels out, but guys, it becomes a 1, right? It doesn't just like disappear and become 0. When the numerator and the denominator, right, when the top and the bottom are exactly the same, right, that's the same as saying 1. Okay, so there's 2 terms in this question, okay, and so there's 2 terms in the brackets for once we pull out the GCF. There's 2 terms here, so again, there's 2 terms there. So just make sure that that's working as well, okay. All right. Whoops, let's scroll that up. Okay. Now, sometimes you're going to have, if one of the numbers is negative and it's the leading number, usually we will pull out the negative as well, okay? So if the first number is negative, your GCF is also going to be negative. And we can take out a 15, D3, 15, D3. Oh. All right. Let's clean that up. Equals negative 15 D3. All right. Hey, here's another reason why I think it's a good idea to do your GCF under each term, because this one is also an example where plus C minus 1. Okay, a lot of people, if you're going to make a mistake on GCF, it's going to be when, okay, there's a plus or a minus 1. Okay, some people just see that, cancel it out, and think that it's 0. Don't forget, okay, C divided by C is 1. All right, and then we've got 6. Okay. The next thing so that's GCF. Okay, so GCF, you guys are going to be superstars with that. The next thing that we looked at, okay, we reminded ourselves how to, okay, oh, here's a couple more, sorry, and then we'll get to difference of squares. Okay, guys, for J, just looking at it, okay, there's no obvious GCF, okay, because I've got a 7, I've got a 10, I've got a 17, and there isn't an M in every single term, okay? So sometimes, okay, so because our expression starts with a negative sign, that's what we're going to take out. We're going to take out a negative 1. Okay, so if I divide everything by negative 1, I end up with positive 7m squared, positive 10m minus 17. Okay, so taking out a negative sign just flips all the signs in the brackets. Okay, and sometimes that's the only thing that you can take out is a negative. And we really only do that when it starts with a negative. Okay, so when it leads with a negative, then we're going to pull out a negative 1. This one was 9p. Okay, and lowest exponent is x to the power 5. So we're going to take out a 25x to the power 5. Okay, and you guys remember exponent laws from grade 10? Okay, so this one is an example of exponent laws. So when you're dividing, okay, and you have the same base, you have an x to the power of 9 on the top and an x to the power of 5 on the bottom. Okay, you keep the base and you subtract the exponents. So 9 subtract 5, that's how we ended up with the 4. Okay, in this case, we're dividing the 50 divided by 25. Okay, that's our 2. And then our exponents we subtract. So 6 subtract 5 is 1. So we just write our x. And then these ones, the x's cancel out. And so we're just ending up with 75 divided by 25, which is 3. Okay, questions, comments? Okay, here's a student solution for factoring. Identify any areas and write a correct solution if necessary. Okay, one of the things that I've always talked about is do your own solution and then compare it to the students, just to see if you can pick up the error that way. So again, I'm looking at this and we're still doing GCF. So I could pull out a 3m from all of those. And I'd be left with an m plus 3m squared minus 1. Okay, so and it looks like the solution that they had, they were missing that final term. Okay, so you have to also be able to analyze student work, right? Pick out the error, do some error analysis. Okay, identify any areas. They forgot the last term. Okay, and again, one way that we know for sure, I'm getting a little annoyed. Okay, one way we know for sure that there was a mistake is because there was 3 terms, and when we took a GCF out, now there's only 2 terms. Okay, so something was missing, so we just have to figure out what that something was. Okay, and that was the last term, and again, it's that when we take out a GCF that's the same as one of the terms, okay, don't forget that it becomes a 1. Okay, and then the final thing that we took a look at, okay, was factoring using the difference of squares. Okay, one of my favorites because I don't know, I just kind of think it's fun. So the thing that you're looking for is first of all, you're looking for just 2 terms. Okay, so difference of squares only happens when you have 2 terms. The second thing has to be true is there has to be a subtraction between the 2 terms. Okay, and then the third thing is that both terms have to be perfect squares. What do I mean when I say perfect square? You guys remember what is a perfect square? Okay, so for example, if I said 7 times 7, you would tell me the answer is 49. Okay, so 49 is a perfect square. So if there's 2 identical things that get multiplied together, that forms a perfect square. So at some point, if you don't already have the perfect squares familiar, I would even say memorized, okay, you might want to, okay, on the side of your paper, okay, you might want to write down the perfect squares. Okay, so for example, this is kind of what I would do. I would say like 1 squared, 2 squared, 3 squared, 4, 5, 6, 7, 8, 9, 10. I usually go to 12. Okay, we'll see. Okay, even 13. Okay, and then I would just like, you can, if you need to use your calculator, you can. Hopefully you can do some mental math on these. Why are these things rolling around, guys? Okay, like they're literally on the bottom of your desks. Yeah, yours usually does go missing. All right. So what we're looking for, these are the ones that we're looking for. The ones on the right, these are our perfect squares. Okay, these are the ones that should send like spidey tingly senses, okay, to remind you that these are the ones that you're looking for. Okay, so 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, and 12 times 12 is 144. Okay, so either you have those like that you recognize what they are, or you can always just write yourself a little sheet like on your scrap piece of paper when you're doing a quiz or a task, just so that you can see them, okay, easily. So for example, okay, so what happens when we solve it, let's just go back to our example here. when you solve it is you're going to take the square root of both of those terms because they're both perfect squares. And your answer is the exact same term, except in one bracket, one's going to be positive, and the other bracket, the other one's going to be negative. Okay? So let's take a look at this. So we have two terms. They're separated by a subtraction sign. Okay, is x squared a perfect square? Yeah, anything squared is a perfect square. Okay? Or like a multiple, any multiple of in your variables, okay, if it can be divided by 2. So for example, x to the power of 4 is a perfect square. X to the power of 6 is a perfect square. X to the power of 8 is a perfect square. Okay? 49, is it a perfect square? We'd like, look here, we're like, oh, it's on the list. Absolutely. So then what you're going to do is you're just going to take the square root of both sides, or like of both terms, excuse me. Okay, and you're going to put the answer. So the square root of x squared is just x, and the square root of 49 is 7. So you're going to do x plus 7 and x minus 7. Okay, so we have an x squared minus 144. Okay, you can either check with your calculator, do the square root of 144, or you remember that, oh yeah, 12 times 12 is 144. Okay, so you have an x plus 12, and you have an x minus 12. Okay, now sometimes there might be a coefficient in front of the x. Just make sure that that's a perfect square too. So 9's on the list. 9's a perfect square. 121 is a perfect square. So we're going to have 3a plus 11 and 3a minus 11. Okay, 81 is a perfect square. X squared is a perfect square. So we have x plus 9, x minus 9. Okay, now these ones, I have no idea. Okay, 324. So this one, I would pull out my calculator. Okay, make sure you know where your square root button is. Okay, square root button should be so you go second. Whoop, let me get out of this for a sec. Quit. There we go, let's clear that. Okay, so your square root button is over here, right? Right above your squared. Okay, so you'd say square root of 384. I guess it wasn't 384. 324, there we go. Okay, 324. It's only a perfect square if there's no decimals. Okay, so it comes out to 18. So we go. So now we've taken the square root of both sides, right? So we have 18a plus 289. 289, 17. Awesome. Okay. Whoops. Let's take the square root of both of them. Okay, this one, they just kind of flip them. Usually we put numbers first, but that's okay. Okay, it's still a perfect square. Okay, and then we have 5x plus 1. Okay, 5x minus 1. That's going to be an x. Okay, now h, okay, here's the thing. H, technically, both of the terms are perfect square. But if you can take a GCF out, you need to take the GCF out first. Because if you take the perfect square of this one, the final answer isn't going to be completely simplified. Okay, so even though you took the difference of squares, okay, you wouldn't get full marks because your answers have to be completely simplified. There can't be any more GCFs in there. Okay, so this one, maybe put a star next to this one. This one you have to do GCF first. Okay, so you take the 4 out, and you're left with x squared minus 9. Okay, and now you have 4x plus 3, x minus 3. Okay, now a question that I asked everybody else was, how many factors are there in that last question? Okay. Some people are maybe not sure, like, do you count every individual thing, right? Like, do you count the 4 and the x and the positive 3 and this x and the negative 3? Okay, no. Okay, we don't count every single term. What we do is we count, so the 4, okay, it's all by itself and it's being multiplied by the bracket. So the 4 is a factor. Okay, and then this entire bracket is a factor. and then the final one is a factor. So this question actually has 3 factors. So if you do combinations, that you take a GCF out and then you do difference of squares, you could have more than just 2 factors. Okay, so if you get 3 factors, or maybe even 4 factors, that's okay. One other thing that I wanted to show you, okay, this one is a personal favorite of mine, okay, that will probably show up on quizzes and tests. So let's say, for example, I gave you x to the power of 4 minus 1, okay, and I asked you to factor that, okay? So go ahead and just like jot it down on the margin or something. So go ahead and do difference of squares on x to the power of 4 minus 1, okay? First of all, is it a difference of squares? Okay, there's 2 terms, there's a subtraction, okay? Are both of these perfect squares? Is one a perfect square? Yeah, absolutely, okay? And any even exponent is a perfect square. Okay, so if we were to take the square root of this, we'd end up with x squared, okay, plus 1, x squared minus 1. Okay, are we done? Why aren't we done? It's not simplified because one of our factors that we just did is still a perfect square. Okay, this one here, x squared minus 1, this is still a difference of squares. Okay, so this we would like this one we're done with. This one we can't do anything more with, so we just write it down again. But we can factor this one. Okay, x plus 1, x minus 1. Okay, so the reason why I say this one is one of my favorites is just because you factored it once doesn't mean you're done. Sometimes you have to like just double check. Is there still a GCF in there? Is there still another difference of squares? Okay, so I love this one because it makes you do it twice. Okay, so if you want full marks, you would have to get to this is the complete factored form of x to the power 4 minus 1. Okay, so if you weren't here on Friday, you'll have to just do number 1 on page 420, okay, when we do homework after today's lesson, okay? All right, now, so this is fresh for everyone. Okay, turn the page. Here we go. Okay, I'll do a couple things, and then I'm going to get you guys up at the board just to kind of move around, right? Because I know it's been a long day. Okay, so we're going to talk about 2 things today. We're going to talk about something, okay, called equivalent ratios, or yeah, equivalent rationals. Okay, this is the exact same thing. Remember when you guys were in junior high and you talked about equivalent fractions? Okay, and so for example, if I gave you 1/2 and I said, okay, you give me an equivalent fraction back. What's the same as 1/2 without it being 1/2? Yeah, 2/4. Okay, or like 3/6 or 5/10. Right, so those are equivalent, so they're the same. Okay, we've either just like multiplied up, okay, or maybe we've divided down. So that's what we're going to take a look at. We're going to talk about, okay, equivalent, and then something called a non-permissible value. Okay, and the reason why we have those is because here's our definition. A rational expression is just this algebraic fraction. Okay, we just have something that has a numerator and it has a denominator, and we've just added some variables to it. Okay, that's all. That's what the rational expression looks like. So here's an example. Okay, we've got this expression on the top, on the numerator, and on the bottom on the denominator. Okay, so what we're going to do is, okay, this just means it has variables. Okay. And rational just means it can be expressed as a fraction. Okay. So let's start with the non-permissible values. So you guys learned probably, you know, as soon as they let you having a calculator, that whenever you take out your calculator and I want you to go 3 divided by 0. Okay, and what do you get? Okay, if you said 0, you didn't actually do it on your calculator. it says error, okay? So for example, okay, so here's my example, okay? 3 divided by 0, okay, gives an error. Okay, the answer is not 0, it is actually an error, okay? So if I do this, 3 divided by 0, okay, sometimes here error, divide by 0. Okay, so your calculator knows that you cannot divide anything by 0. Okay, because the fact that you're trying to divide things into groups and then you say no groups, it's like, no, we can't do that. We like need to know how many to put in each group. Okay, so what happens is when we divide by 0, it gives us an error. So we just say that this is a non-permissible value. Okay, it gives us an error, or we also call this undefined. Okay, that's the technical math term. Okay, so when you have something that and you end up having to divide by 0, we say, no, that's undefined. Okay, we can't do that. So you can see here with this rational expression, I have something on the denominator, and we just want to put a restriction on it. We can say x can be any number except the number that makes that denominator equal to 0. It just can't be that one. It can be any other number, just not that one. Okay, so here's what it looks like. Okay, the first thing that we do is we take our denominator, remember the denominator is the bottom number, okay, and we set it to not equal 0. So in this case, we're just going to go 5x squared minus 5x, and we use this symbol, not equal to 0. Okay, so this is our restriction. Okay, now we just need to factor it, right? We just want to clean it up. Okay, so we're going to take out, so we're going to use our combination, we're going to use greatest common factor, and DOS just stands for difference of squares. Okay, so just depending on the question, you're going to look for greatest common factor first and then see if there's a difference of squares. So in this case, I'm going to pull out a 5x and a 5x, and I'm left with 5x. Okay, my handwriting's gotten sloppy here. 5x, x minus 1. Okay, and we still say, so we factored it, it's still not equal to 0. Okay, but this is it in factored form. Okay, and then we just set each factor to not equal 0. Okay, so that means that here's one factor, and here's our other factor. So we're saying that 5x cannot be 0. Okay, and then we're also saying that x minus 1 cannot equal 0. So we set each factor to not equal 0, and then we just clean it up a little bit, and you just solve for x. Okay, solve for the variable. So what? Remember, don't forget, like this is going back to junior high. So when we have 5x, okay, we divide both sides by 5. Can you do 0 divided by 5?
Yes.
Yeah, that's okay. You can go 0 divided by something. You just can't go something divided by 0. Okay, 0 divided by 5 is still 0. So x cannot be 0. And here, we get x on one side, okay, and all the numbers on the other side. So this is just saying x cannot be positive 1. Okay, so we have 2 restrictions on x. And let's just go back and see why. Okay, if x was equal to 0, okay, in my original question here, if I substituted x is equal to 0 in, I'd have 5 times 0 minus 5 times 0. So 0 minus 0 is 0. So I'd have a 0 on the bottom. Well, we can't have that. So that's why x is not allowed to be 0. Okay, what if we substituted in 1? Okay, 5 times 1 squared is 5 minus 5 times 1. That's 5. 5 minus 5, 0. Okay, we can't have that. So that's why x is not allowed to be equal to 1 either. Okay, so when you have a rational expression, you're just going to take whatever is on the denominator, you're going to factor it, and you're going to say it cannot equal 0. Then you're going to solve for x. And those are your, what we call, non-permissible values. Okay, so this is, so non-permissible values we are allowed to short form those. Okay, we're going to call them NPVs, non-permissible values. Okay, so here are our two restrictions, our NPVs for our question. Okay, so here's an example that we're going to do. For each rational expression, determine the non-permissible values. What are the restrictions? Okay, so we're not doing anything more than just stating the NPVs. Okay, so the first thing that we do is we take the bottom number and we set it not equal to 0. Okay, factor it if needed. Can we factor that? Do we need to factor that? No, it's as simple as it can get. Okay, all we have to do is isolate for x. Okay, so when we have a plus 4, right, then we do subtract 4 on both sides. So x cannot equal negative 4. So that is our NPV. Okay, if you're feeling like you're getting this, do the next two. Okay, you're going to set the denominator not equal to 0. You're going to factor it. And then you're going to set each factor not equal to 0. So this means that k cannot equal 0, and whatever's in the brackets cannot equal 0. I'll move that up for some of you. Okay. And then this one we just simplify a bit more, right? We're going to add 1 to both sides. So we have 2k cannot equal 1. And then we divide by 2. So k cannot equal 1/2. Okay, so this one has 2 restrictions. You remember how to do that? I see some cringy faces. Ah. All right. Final one, we have 2m plus 10 cannot equal 0. I'm just going to factor that, take a 2 out. Okay, guys, do we need to do anything with the factor of 2? Because before, right, if we had a variable, we set variable cannot equal to 0. But does it make sense to say 2 cannot equal 0? No. Okay. The 2 you don't have to do anything with. You're only interested in the factors that have variables in them. Okay, so in this case, this only has 1 restriction. Okay, and it's this factor right here. Okay, so m cannot equal -5. Okay, now if for some of you, okay, you can do this mental step. You could put the 5 to the other side, okay, and get the signs right. So if you want to show me that you've set your factor not equal to 0, and then you got to m cannot equal -5, awesome, you can do that. Okay, for some of you, you like to just be a little bit more organized and show me all the steps. Okay, in which case, if you want to do, like show me that you're subtracting 5 from both sides, I'm okay with that too. Okay, I will take either. If you don't need to show me the middle step, you don't have to. Okay, but just make sure you don't mess up your signs. So sometimes it's good to show all the steps. Okay, so that's NPVs. They're not difficult. You just set the bottom term. You say cannot equal to 0. We're going to practice our factoring, okay, and then isolating for your variable. Okay, if you guys are feeling good, why don't you head up to the boards and do the next 3 questions. So you can look up here, or you can bring your notes package with you. Okay, and we're going to answer these ones. There we go. All right, so you guys were just up at the boards. We're just summarizing. X squared minus 49 cannot equal 0. We knew this was a difference of squares. X plus 7, x minus 7 cannot equal 0. So x plus 7 cannot equal 0. X minus 7 cannot equal 0. X cannot equal -7. X cannot equal +7. Okay, so this This is showing all the steps, okay, where you set each factor not equal to 0 and then you solve for x. Okay, so if you're not sure, just go back to like taking it back to each individual step. Okay, this one, you guys had negative 2x minus 4 cannot equal 0. Okay, for this one, some of you like ended up with a negative x, okay, and we talked about dividing out a negative 1. Okay, however, if you took a GCF out of this, and your GCF was negative 2, okay, that would have cleared up, okay, having a negative x. You would have ended up with x plus 2 cannot equal 0, right, because we would have taken out a negative 2. Okay, but even if you just took out a 2 and you ended up with the negative x minus 2, okay, we were able to get through that one. Okay, so this is x plus 2 cannot equal 0, and x cannot equal negative 2. X plus 2, x minus 2 cannot equal 0. So this one I am okay. Okay, if you guys want to say x cannot equal 2, x cannot equal negative 2, okay, that's one way that you could write it, which is great. Okay, some of you said x cannot equal plus or minus 2. That's also great. Okay, you can just stack them. If they're the same number, you can just say plus or minus 2 that way. Okay, so these two are the same thing. You don't have to do both. You just do one or the other. Okay, so you could do one or the other. Okay, either separate them out, or if they're the same number, you could stack them. So same thing here, right? You could have also said x cannot be plus or minus 7. Okay, all right. So that's non-permissible values. Okay, so whenever we have a rational expression, okay, you're always, even if it doesn't ask you for them, you're always going to state your non-permissible values. Okay, usually it will say state non-permissible values, but just in case, like when we do a word problem, the word problem doesn't always like tell you all the steps that you need to do. So if you're doing a word problem, you still have to state non-permissible values, even if it doesn't like ask you to. Okay, so that's just something, file that one away. Okay, we're always going to state non-permissible values when we are dealing with a rational expression. Okay, now let's go back. At the very beginning, we talked about equivalent fractions. And we were kind of doing some of those examples of like 1/2, and the equivalent fraction would be like 3/6 or 2/4. Okay, so here, write a rational expression that is equivalent to 8/12. Okay. Somebody be brave and tell me what they would do. You don't have to tell me what it is. Just tell me what you would do to get an equivalent fraction to 8/12. What would you do? Yeah, what would you do? Oh, you're mean. Okay, you could. Okay, because he said it, we're going to do it. He said multiply. Okay, and you literally, you pick a number. Okay, don't pick 42. Okay, pick a nice number that you can do in your head. Okay, but to write an equivalent fraction, those are the steps. Yes. Can you just wait till we're just done this part? Yeah. Okay, so here's the thing to remember. Whatever you do to the top, you have to do to the bottom. Okay, that's how you keep it equivalent. Equivalent means the same. Okay, if this were me, I probably would have done like 8 times 2 and 12 times 2 in order to get 16/24. Okay, guys, you can multiply up to get an equivalent fraction. What else could you do? Yeah. 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 Absolutely. Okay, you could do this. You could go 8/12 if I divide top and bottom by 2. Okay, so an equivalent fraction you can also get to by dividing both the numerator and the denominator by the same number. Okay, and we had multiple options. Okay, Elise chose 2. We could have divided top and bottom by 4. Okay, that would be another equivalent fraction. Okay, now here's one. Now we're just going to change it up a little bit. Now we have 4x squared plus 8x all over 4x. Okay, guys? Okay, walk me through what you would do to write an equivalent expression when we've thrown in some variables. Okay, what's something that we could do? We could, did you say multiply or divide? Okay, we could divide everything by 2. Absolutely. Absolutely. Okay, so you could, okay, now when we divide everything by 2, we literally mean every single term. Okay, so we would have to like divide this by 2, we would divide this by 2, we would divide this by 2. Okay, everything needs to be divided by 2. Okay, so this would be 2x squared plus 4 all over 2x. Okay, that is an example of one equivalent fraction. Okay, what's something else you might do? Oh, did I miss an x?
Yes.
Thank you. You're right, the x just doesn't disappear or fall off. Okay, what else could we do? Okay, we divided by 2. What's something else we could do for an equivalent? Okay, we can multiply. Okay, we can multiply. So what if we did, okay, so we have 4x squared plus 8x all over 4x. Okay, what if we multiplied everything by 3? Okay, you might see it written like this, okay, where we just put the whole top in brackets. Okay, whatever we do to the top, we have to do to the bottom. I'm just going to show you different ways that we can write it. Okay, when I write it like this, I'm implying that there's a multiplication going on. Okay, sometimes we write like here, times, times. Okay, sometimes we just write it in brackets, and this means that we're multiplying. There's like a dot or a little times that's in there. Okay, so don't forget when we multiply, we have to multiply that 3 by everything. Okay, so this would become 12x squared plus 24x all over 12x. Okay, yeah, that would be an equivalent. Okay. Okay, not by decimal, not going to be decimal. Okay, but what about the variable? All the terms have a variable in it. Could we divide by the variable instead of by coefficient? We could. Okay. 4x squared. I'm just giving you lots of. Okay. So if we divided by x, okay, just don't forget we have to divide everything by x. So this would be 4x plus 8 all over 4. Okay, so if we divided everything by x, some of the x terms would drop out. Okay. Now, okay, so we've kind of played around with this because we're going to be using this later where we have to find equivalent expressions for our rational expressions. Okay, state the NPVs for part B. Okay, whenever you have to state the NPVs, you always go back to your original question. Okay, because you look at this one, okay, it's an equivalent expression, but like, look, there's no x on the bottom anymore. So you might be tempted to say, well, if I chose this one, there's no NPVs, okay, which is not the case. You always go back to the original question and do the NPVs for that. Okay, so make a note to yourself. Okay, NPVs for original question. So just in case when we're simplifying things, if things kind of like divide out or disappear or we've done things, okay, always do your NPVs for your original question. So in this case, the original question, okay, 4x cannot equal 0, so x cannot equal 0. Okay, we just set the denominator not equal to 0, and then we solve for that. Okay. B, for each of the rational expressions, determine, okay, decide if they are equivalent. Okay? So one of the things that you can do is you can take a look at this and you can say, what did I do to 9 to get to 18? Yeah. Okay, so if I multiplied by 2, then we just have to double check. Whatever I do to the bottom, or sorry, whatever I do to the top, I have to do to the bottom. So is it also true that if I multiply everything on the bottom by 2, will I get the expression on the right? Okay, so if I do this, minus 1, okay, and I multiply everything by 2, okay, I end up with 9 times 2 is 18. And on the bottom, I just multiply the 2 through. So I have 6x minus 2. Oh, and that's exactly what we have on the right-hand side. So then I could say, okay, yes, okay, these are equivalent. Okay, but you need to look at both things and you need to find out what the key is, what the clue is. Here, the clue was recognizing that if I take 9 and I multiply it by 2, I get 18, and I just check the bottom. The same thing. Okay? How about these two? Okay? I would probably look at the bottoms and say, how could I go from 4x to 2x? Yeah. You could divide by 2. Okay, so let's try that one. Okay, if I'm going from here to here, okay, I'm dividing by 2. So let's put it to the test. And if I divide everything by 2, okay, then I get 2 divided by 2 is 1. So I'm just left with the x. 2 divided by 2 is 1. 4 divided by 2 is 2. And then I still have my x. Okay, which is what I got on the right-hand side. So this one, okay, is also equivalent. Now, is this the only way? Like, could you only have multiplied by 2? Could you have started on the right-hand side and could you like divide it? You could have. Okay. Same here. You could have started on the right-hand side and said, okay, how do I get from 2 to 4 and multiplying by 2? Okay, so it doesn't matter which way that you see it, as long as when you do, so whatever you do, you got to do both to the top and to the bottom. Okay, I wish actually there was a non-example. Okay, I'll develop one. All right. Final example. Okay, and then I'll get you guys doing a little bit of practice questions. Okay, so in this case, in each case, write in a rational expression with the given variable and non-permissible values. Okay, so guys, now we are reverse engineering, okay, the process. They're giving us the answer, so they're telling us the variable is x, okay, and the non-permissible value is 3. Can you create the rational expression? Okay, how would you do that? Let's see, he's working it out. Okay, so just take what you know. If you know the non-permissible value, so at NPV, so they've given us the variable, and they've said that x cannot equal 3. That's what the non-permissible value is, 3. Okay. Okay, so if you know that x cannot equal 3, can you turn this into a factor where we had like brackets and we had it equaling 0? Okay, what we're trying to do is we're trying to go from here and we're working our way up this way. Okay, so we knew what to do when we had an x plus 7 can't equal 0 and we isolated for x. Now we have the x can't equal, and now we want to get it back to the can't equal 0. Okay, so in order to do that, we want to see the equal 0. So right now we have a positive 3, so if we subtract 3 from both sides, 3 subtract 3 is 0. So we have x, let me clean that up, x minus 3 cannot equal 0. Okay, so we're looking for our cannot equal 0. Okay, and so now we know if it has a non-permissible value, it just means that this expression is on the bottom. Okay, so this right here, okay, is on the bottom. Okay, what can we put on the top? You put a 1 on the top. You can put anything you want on the top. It does not matter what you put on the top. The important thing is, okay, the key to this one is starting with your non-permissible value, that has to be on the bottom. That's the only thing that really matters. What you put on the top is up to you. You could put another, you could put, you know, x squared plus 3x. You could put negative 17. You could put whatever you like on the top. I'm just going to make it easy. I'm just going to put a 1 on the top. So that it's now a rational expression. Okay, rational means it's in fraction form, and it has a non-permissible value of x cannot equal 3. Okay? Okay, you guys, okay? Next one. You're good? Okay, so this one, now we're just changing the variable. We're just calling it p. Okay, and our non-permissible value is 1 over 3. Okay, so we're just going to write p cannot equal 1 over 3. Okay, don't forget how to do this one, guys. I'm trying to think if we, okay, where did we do? I'm just going back through our notes for a quick sec. Hey guys, look, this is what it looked like when we had a non-permissible value with a fraction. Okay, when we worked it back, okay, it just means that we end up with something on the bottom that has a number in front of our variable. Okay, and that's it. So the way that we can get to this point here, okay, we're just going to, okay, we want to get rid of the fraction. So if we multiply both sides by 3, okay, 3 divided by 3 is equal to 1. Okay, so our 3's cancel. And now we have 3p cannot equal to 1. And if we take away 1 on both sides, we have 3p minus 1 cannot equal 0. You see how I did that? Okay. So if you have just a number, you're just going to either add it or subtract it to the other side so that you get some sort of expression cannot equal 0. If you have a fraction, you're first going to multiply by the denominator of the fraction. Okay, and then you're going to add or subtract the number that's left over. Okay, and then from here, we know that 3p minus 1 is on the bottom. What do you want to put on the top? What do you want? 1. Sure. Okay, you can have 2p. You can have anything that you want on the top. Okay, final one. Now we have a variable m, non-permissible value. M cannot equal -8. Okay, guys, you can do this. Go. Okay, give me a rational expression with that as a non-permissible value. You can. What's going to be your denominator? No. You have to have a variable. Oh, no, it's got a... Okay, your notes are looking a little incomplete compared to what I have on the board. Okay, so this is your non-permissible value. You have to rearrange it so that you see it not equal to 0. Then you put that on your bottom. Yeah. Okay, anybody want to walk me through their process? Okay, what'd you do? Be brave. No, are there any other brave people? Okay, what you got, Cole? Yeah. Okay, so the key here is you want to see the cannot equal 0. Okay, so in order to get this to be equal to 0, you're just going to do the opposite sign. So it was a -8, you're going to add 8 so that you get 0. and then you know that this is now your denominator. Okay, and let's do something interesting. Let's just put, instead of a 1, let's put a 2m. Okay, or anything else that you want on there. Okay, so go ahead and get your workbooks. Okay, and we're going to just work on a couple questions to get a little bit more practice in.